Hello students. So today we'll be seeing about Unit 5 and here you will be seeing in detail about human machine interface. So this is today's agenda. So we'll be saying HMI in an automation process. So HMI is nothing but human machine interface. So we'll see basically what is human machine interface. So it is a user interface and it's considered to be connection to a machine system or a device. So the term can technically specify any screen that allows a user to interact with the device. Okay, so any screen can interact with the device, and this HMI is most commonly used in the context of an industrial process. So when you consider this type of systems, it is used via graphical user interface, but GUIs are often used along for visualization capabilities, which is used mainly for industrial settings. Okay, so uh, basically, if you understand HMI, it's a user interface that connects a person to a machine, a system, or a device. So you can any screen that can allows a user to interact with a device. That is commonly we call it as a human machine interface. So here we have similar in some ways. It is represented as graphical user interface, and it is mainly used for visualization capabilities. And in industrial settings, we can use all these type of displaying the data and so on. So we can usually visualize display data. We can oversee machine inputs and outputs and so on. And when you consider here in this particular topic, it would interact with the other systems to check and control some features in the network. Okay, so here you have an example. So this type of system can interact with an air conditioning system to check and control the temperature in a house. So a plant floor operator might use HMI to check and control the temperature of an industrial water tank. So we can track all these processes, and we have some basic examples which can include built-in screens on machines, computer monitor, and tablets. But regardless of these particular formats, which we can use or refer them, their purpose is to provide insight into mechanical performance and progress. So here you will be learning about uses of HMI. So when you consider these type of systems, I told you it's mainly used to display data. We can track the production time, other trackings and so on. We can monitor machine inputs and outputs and so on. So first basically you have to understand where you will be using HMIs. So HMI technology is used by almost all industrial organizations, and which is also used worldwide to interact with their machines and to optimize their industrial processes. So we have some industries which include using HMI includes energy, food management, manufacturing. It is used in gas and oil, power, recycling, transportation, waste and wastewater management, and many more. So the common roles is to interact with the HMI's operator. So the system integrators and engineers, particularly control system engineers, can interact with each other to have some basic information and for monitoring purposes. So HMIs are essential resources for these professionals who use them to review and monitor the process, diagnose problems, and to visualize the data. So HMI screens can also perform single function. So HMIs are used to optimize an industrial processes by digitizing and centralizing the data by a viewer. So by leveraging all the HMI concepts, we can use operators. We can see important information displayed in graphs, charts, or other digital dashboards. And also we can view and manage alarms. We can connect with SCADA systems, ERP, and MES systems all through one console. So that's the main advantage here. So when you consider the operators would head to walk the flow consistency to review the mechanical progress and record it on a piece of paper or a whiteboard. So by allowing PLCs to communicate real-time information, we use PLCs to communicate straightforwardly with the HMI display. So HMI technology will eliminate the need of its outdated practice, and it reduces problems caused by lack of information or by human error. So operators also need review mechanical process, and they can record all the information. Many errors can be eradicated by using this type of process. Next, we'll move on to learn the difference between HMI and SCADA. Okay, so here you will be learning about the differences. So when you consider SCADA systems, uh, it has a distinct role in unified industrial control. So we will be using SCADA very frequently. And when you consider human machine interfaces, they are an integral component of modern industrial control architectures. So, though often mentioned together, they serve distinct, but they have some complementary functions. So, when you consider HMIs, it acts as a visual and interactive layer. So, these particular visual and interactive layer enables the operators to monitor and manage the industrial processes. So, all these processes can be done in real time. So the primary role you have to understand, the primary role is to present data in a intuitive format through we can achieve through dashboards, gauges, and alerts. So it also facilitates human oversights and decision making. So when you compare it with SCADA, on the other hand, it can encompasses a broader scope. So it not only interfaces with HMI but also handles data acquisition. So it can also be used in historical logging, remote control, and it can also integrate with the databases and the enterprise systems. So SCADA systems provide the backbone for centralized monitoring, analytics, and automation across distributed assets. So when you consider HMIs, it focuses on user interaction and visualization, whereas in SCADA systems, it delivers the infrastructure for data-driven control and for operational intelligence. So both of these form a powerful synergy in industrial automation. So when you compare developing trends in HMI technology, changing operational and business needs has become interesting, where developments in HMI technology is very useful. So it becomes more common to see evolved forms of HMI. So we have some examples for HMI, which includes high performance HMIs, where we can use along with touch screens and mobile devices, along with more traditional models. So these modernized interfaces are creating more opportunities for equipment interaction and analysis. So when you consider the high performance HMIs, operators and users are increasingly moving towards high performance HMI. So they are using a method to ensure fast, effective interaction and so on. So all these attention has to be considered, and they are managing critical indicators on the interface, and they have design techniques which helps the viewer to see and respond to problems more efficiently. So the thing is, we have some other design elements in HMI where we will be having color, size, placements are used with the used to optimize the user experience. So we have so many tips to develop a HMI interface. So here you will be seeing about the types of HMI. So the first type we call it as graphical user interface. The second type touch screens. The third we call it as physical control panels. And fourth we call it as web-based HMI. So there are several different types of human machine interfaces which we can take a variety of forms depending on the needs of the application. So the first type we'll see about graphical user interface. So already you know about graphical user interface. So these are computer based HMI that use a graphical interface to present process data, and it also allows the operator to input commands. So when you consider GUIs, it can be created using software such as Microsoft Windows or a specified HMI software package. So this is all about graphical user interface. So HMIs can communicate with programmable logic controllers, and it can input output sensors to display and display information for users to view. So we can also use HMI screens that can be used for a single function like monitoring and tracking, and it can perform more sophisticated operations like switching machines off or increasing production based on speed depending on how they are implemented. So everything can be considered here. So next we'll move on to the next type of HMIs. So here we'll be seeing about graphical user interfaces is over. So next we'll be seeing about touch screens. So here when you consider touch screens, uh, it gives a basic operation like a display operation to present process data, and it allows the operator to input commands. So they are often used in applications where we can consider physical control panel, which is not practical, but it is used in this environments where the space is very limited. So when you use touch screens based human machine interface are used, which allows display of real-time process data and enable operators to interact directly with the system. So these interfaces are especially valuable in settings where traditional physical and control panels are impractical. So here will be using some space constrained environments offering streamlined space efficient solution without compromising functionality. So when you consider physical control panels, these are physical HMIs that use buttons, switches and displays where it is used to present process data, and it can allow the operator to input commands. So they are often used in industrial settings, and they'll be using GUIs or a touch screen, and it may not be practical. And such environments with high levels of vibration or dust is also possible here. So next we'll be using some physical human interfaces. So basically it relies on tactile components such as button switches and indicator displays. So whenever you use these types of components, it is used to convey process data and can enable operator control. So these type of interfaces are very robust, and they are used ideal for industrial environments. So these type of graphical or touchscreen systems may be unsuitable, particularly in some conditions involving heavy vibration, airborne particulates, or other factors that challenge delicate electronics. So their durability and straightforward operations may make them a reliable choice for mission critical applications. So moving on to the fourth type of HMI, we will be learning about web-based HMI. So these are HMIs that use a web browser to present process data, and it allows the operator to input commands. So these type of web-based HMI can be accessed from any device with a web browser, and it allows operators to monitor and control processes remotely. So when you consider this web-based human machine interface, these type of interfaces deliver process data and it can control the capabilities through standard web browsers. So it enables operators to interact with industrial systems from virtually it can be connected with any device. So this platform independent approach supports remote monitoring and command input without the need for specialized hardware or software installations, making it ideal for distributed operations, mobile access, and scalable control environments. So already I've learned about some differences. So HMI technology eliminates the need for this outdated practice, and they reduces cost problems caused by lack of information or human error. Uh, so in the recent past decade, changing operational and business needs have instigated interesting developments in HMI technology, and nowadays it is more commonly used, and we have some more advanced HMI examples or which can be used for high performance HMIs like touchscreen mobile devices and used more in traditional models. So these modernized interfaces are creating more opportunities for equipment interaction, and it is used for analysis. uh, so, Here, when you consider web-based HMI, it can perform remote monitoring. So, mobile-friendly remote monitoring allows uh, flexibility and accessibility for operators and managers. And we have so many scenarios to represent this. So all these things will make you understand the human machine interface, and you would have known the types, and you will be in the other slides you will be learning about how the interface works and what are the use cases we can apply here, and how we can choose an HMI. So that all we'll learn in the upcoming slides. So here when you consider this particular slide, you will be learning about choosing an HMI. So choosing an HMI is very important. So it is mainly used for industrial processor system. There are several factors to consider or to ensure the HMI is the best fit for the specific application. Okay, so first we'll be seeing based on compatibility. So it is important to choose an HMI that is compatible with the equipment and systems, and that it will be controlling all the operations and other monitoring controls. So this includes compatibility with the control system, communication protocols, and data formats used by the environment. So when you consider hardware, the HMI should be designed to be rugged and durable, so which is suitable for the environment where it will be installed. So it should be able to withstand the temperature, humidity, and vibration that it is exposed to. So when you consider display, the HMI should always display that it is very clear, easy to read, and easy to navigate. So the display should also be considered. So the screen should be of good resolution with a high quality display and backlight. So moving on to the usability, the HMI should be easy to operate and understand. There should be a clear-cut navigation, and it should consist of concise displays. It should be easy to use and understand operators with different levels of expertise. Next comes the data visualization. So the HMI should be able to display data in a clear and meaningful way. So here you will be using graphics, charts, and other types of visual representations to help operators understand the process and make informed decisions. So next it is customizability. So the HMI should be customizable with the ability to adapt to the specific needs of the process or equipment. As well as we have to consider some preferences of the operator. So based on the remote access, the HMI should be designed to allow remote access so that operators can monitor and control the process from a remote location. Next, we'll move on to scalability. So here in this particular thing, we'll consider a particular HMI that should be designed to be scalable, where with the ability to handle more complexity and data as the process or equipment becomes more advanced. So this has to be considered here. And moving on to the support, the HMI vendor also should provide good technical support and documentation, as well as he has to give some software updates and upgrades. So moving on to the cost, the HMI should be cost effective and it should provide a good return on the investment. So here we have some adaptabilities where ensuring the HMI is fully compatible with the control systems, communication protocols like Modbus, OPC UA, and data formats, which is used by equipments, and it is used for seamless integration where it minimizes configuration overhead and it ensures the reliable operation. So these all can be considered under system compatibility. And moving on to the robustness of hardware, the physical design should match the environment, which where it demands the installation site and so on. So HMIs are built to withstand temperature extremes, humidity, dust, and vibration, especially in industrial or outdoor settings. So moving on to display quality, a high resolution screen with strong backlighting and clear visuals is critical. So the interface should be easy to read and it should navigate with the high resolution, or we can say like even in low light or in high glare conditions. When you consider the usability, so already we have discussed the HMI should offer intuitive navigation. So where we can get clear labeling or we can have streamlined workflows and so on. So here in usability, it must accommodate users with varying levels of technical expertise, so we can reduce training time and operational errors. So next it is data visualization. Already we have discussed. So again I'll tell you, it's nothing but the effective HMIs. We can represent process data where we have some meaningful visualizations such as real-time graphs, charts, and so on. So these all things enable operators to quickly interpret system performance and it can make informed decisions. So next we have customizability. So the interface should be adaptable to specific process requirements, user preferences, and so on. So here custom layouts, alarms, and control elements enhance the operator efficiency. So remote accessibility is nothing but it supports for remote access where it allows operators and engineers to monitor and control the system from the offsite location. So it can also improve the responsiveness and operational flexibility. So next we have scalability. So choosing an HMI so that can grow with your system, it should support increasing data volumes. It should handle additional devices and it should also have some more complex control logic as per the operations evolve. Based on the support, we should consider the vendor support that should be reliable with technical support, comprehensive documentation, and regular software updates are needed. So these all things has to be maintained and it minimizes downtime and it also ensures long-term system health and so on. So based on the cost, it's on the cost efficiency. So selected HMIs should offer a strong return on investment. So it can balance upfront cost with long-term benefits such as reduced maintenance, improved productivity, and enhanced systems visibility. So next we are learning about advantages of human machine interaction. So there are so many advantages by you in human machine interaction. So yeah, so here we'll be seeing about some interfaces where we can apply in HMI technology. So more advanced HMI performance are used nowadays. So these modernized interfaces are useful for creating more opportunities for acute interaction and analysis. So the thing is, uh, here you will be seeing some advantages. So I'll list a few. So in human machine interfaces, we have several advantages which is used for controlling and monitoring industrial processes. So the first thing, it is based on improved efficiency. So HMI allows operators to easily access process data and inputs commands. So we can improve the efficiency of the process by its control operations. So by representing the data in a clear and concise manner, operators can make more informed decisions and they can take timely actions whenever necessary. So moving on to the increased safety. So HMIs can improve safety by presenting alarms and other important information to the operator. So this allow operator to take time action to address potential problems before they become serious. So moving on to remote monitoring and control. So there are many HMIs we can interface with this control process. So many HMIs can be accessed remotely, allowing operators to monitor and control processes from a distance. So this can be particularly useful in applications where we can consider processes located in a remote or hazardous locations. So next we are considering easy to use. So here HMI is designed to be easy. So even for operators who are not well versed in technical expertise. So this makes them accessible tool for controlling and monitoring industrial processes. So next we'll move on to disadvantages of human machine interface. So first you have to understand the disadvantages. So it has some potential disadvantages that should be considered when determining whether to use one or the other. So when you consider dependency on the HMI, so if the HMI fails or become yeah. So if the HMI fails or becomes unavailable, the operator may not be able to access or process data or input commands. So this can hinder the operation of the process being controlled. So that's the main disadvantage. The next we'll move on to potential of a potential for human error. So when you consider this disadvantages, operators can make mistakes when using HMI. For example, mistakes like inputting incorrect commands or failing to notice an alarm. So these particular things can lead to problems with the process being controlled. So it's considered to be a potential for human error. And next we'll move on to additional cost. So considering additional cost, it is based on implementing an HMI can be used with additional cost as it reduces the purchase and installation of the HMI itself, and we can associate with hardware and software. So moving on to the complexity, some HMIs can be complex which can make them difficult to use or require additional training for operators. So this can be a disadvantage in applications where the operator needs to be able to access quickly or the processing of data and input commands has to be considered. So these are all the disadvantages. So it's based on dependency on the HMI, potential for human error, additional cost, and complexity. So moving on to the next part, it's based on applications. So here when you consider applications, we have a human interface, machine interface is used by variety of variety of industrial applications where they can help improve efficiency, safety, and accessibility of the process being controlled. So there are some applications we can use it in manufacturing. So HMI is commonly used in manufacturing settings to control and monitor production processes. So they can also be used to present process data to operators, and they can allow them to input commands, and they can present alarms and other important informations and so on. So this is the first application. And moving on to the second application, it is power generation. So HMI is also used in power generation plants, uh, and they use fossil fuels or other renewable energy resources where where they can monitor and control processes such as boiler operation, turbine control, and electrical generation and other distribution operation. So next application is water and wastewater treatment. So here HMI is used in water and water waste treatment, where they can control and monitor processes such as pumping, treatment, and distribution. Next we have oil and gas. So HMIs are used in oil and gas production, and it can refine to control and monitor processes such as drilling, pumping, and refining. So next we have chemical processing. So HMI is used in chemical processing plants to control and monitor processes such as mixing, reaction, and distillation. So these are all the applications here. So when you consider all these applications, so everything should be represented in a screen. So here you will be able to specify, you should have a menu where where it should have all the operators like auto on, manual off, manual mode, etc. should be considered here. And whenever you perform each type of operation, it should specify what operation has to be performed, so for how long it should be performed, and so on. Everything has to be monitored, and some decision making can also be performed. So when you consider all these types of HMIs, there are some common types, already I told you. So types like graphical user interfaces, touch screens, physical control panels, and web-based HMIs are mostly used nowadays. And these type of HMIs can take variety of forms. For example, we can include it in GUIs, we can use it in computer touch screens or physical control panels with buttons and displays and so on. So they are used to represent process data to the operator, and it allows the operator to input commands and to set some points, and it can perform other activities and other information. So basically these type of devices or HMI interfaces is typically connected to programmable logic controller, which is responsible for controlling the process based on input from the HMI, and sensors are also used in the fields. So in HMI, it simply presents information to the operator, and it allows them to input commands which are then sent to the PLCs, where we can implement all these things. So we have other things. So peering into the future of HMI should also be considered here. So leading engineers are even exploring ways to implement augmented reality and virtual reality in HMIs, so they can visualize manufacturing functions and so on. So as data takes on increasingly essential role in manufacturing, we are considering this HMI interfaces where we can implement along with the augmented reality and virtual reality. So this technology may become very important, and this technology may have come a long way, but its potential for growth remains virtually limitless. So we will be having high performance HMIs also, So these high performance HMIs can use operators and users where they can consider increasingly moving towards high performance interfaces where we use different methodologies that helps HMI design that can ensure fast and effective interaction. So only by considering all these attention, we have some critical indicators on the interface. So this design technique helps the viewer to see and respond to problems. So it can be managed efficiently as well as it makes better informed decisions. So indicators are very much important and it can be used on high performance HMIs. So they are simple, clean, and it can give some extra additional informations on graphics or other controls. So other design elements like color, placement, so it is used to optimize the user experience. Uh, so basically you would have understood the difference between HMI and SCADA, and you know the purpose of using HMI. So this HMI communicates with programmable logic controllers. HMI screens can be used for single function like monitoring and tracking, and it can also perform more sophisticated operations like switching machines off or increasing production depending speed increasing production and speed depending on how they are implemented. Uh, so this particular information is very much needed to develop a particular systems. So whenever you are using along with different applications, we can use along with programmable logic circuit in the field where we'll be reading the input fields and we can write the outputs depending on how it is programmed. So along with PLCs, along with the SCADA network, asynchronously we can receive and execute certain commands by using this type of interfaces. So this can help in increasing network, and we will be having so many sources of data where we can apply visually displaying the data and other tracking processes and so on. So this is how we'll be interacting with various applications. So this particular field has helped us in industrial organizations to perform various missions and optimize their industrial processes. There are also so many roles and other responsibilities with the HMI's operators. So system integrators are also used along with this HMI interfaces, and it can particularly used in control systems, and control systems are which is controlled by control system engineers. So HMIs are essential resources for controlling, and they can review and monitor processes, diagnose problems, and they can visualize the data. So there are also so many uses here by using HMIs. So HMIs are used to optimize an industrial process. So everything is digitalized nowadays, and they have centralized data for viewing and for outsourcing. So operators can see important information which is displayed on graphs, charts, and other digital dashboards. So this can be used via with HMI technology, so that can eliminate the need for this outdated practice, and thereby it can reduce many cost problems caused by the lack of information or human error. So thus we have started using HMI technologies in various applications. There are also so many advanced HMI examples where we can include high performance HMIs, touchscreens, mobile devices, and also it is used along with the traditional models. So these modernized interfaces are used along with various high performance HMIs, where it is used along with edge of network and cloud HMIs. So I'll give you a brief intro about edge of network cloud HMIs. So this is a network which has high demand. So it allows operators to access data, and it also visualizes some field devices. So additionally, it is becoming more common to send data from local HMIs to the cloud. It can be accessed and analyzed remotely while keeping control capabilities local. Along with the future of HMI, we are leading with the augmented reality and virtual reality to visualize manufacturing functions. So, as data takes on an increasingly essential role in manufacturing, the future looks very bright for HMI. So, this particular technology is very useful, and it has potential for virtual limitlessness. So that's all about human machine interface. So next we'll continue with the last topic. So thank you all.